Uh, what I am going to do is interface the major theme of this short term course, which is on automation, with something that is equally important and needs to be connected with it, and that part is the production scheduling. Automation, as far as the production function is concerned, I am sure you must have listened to, gone through all the details of it. What I would like to bring to you is another aspect which goes hand in hand with the automation technology that you are trying to do. If you look at the production situation or manufacturing, it started in the early days with mass manufacturing, which meant you had practically negligible variety to produce and the numbers were large. A typical example is the Ford manufacturing system, which started with manufacturing the T model, and as the famous saying goes, Ford used to say, you can have any color Ford car as long as it is black. So, the variety was not even available in terms of colors, right. So, those days where mass production started, and we are moving towards something in the future which we already must have heard about, is called as mass customization, right, which basically means every product that is going to be produced will have an identified customer. The specification of the product will be what the customer has given, and the total quantity that will be produced is going to be large. So, we are going to do mass production, but a huge variety to the extent that every product coming out of the production line or every product that is being produced is going to be different and tailored for a customer. Now, we are yet to reach that stage. We are somewhere in the middle where the product varieties are increasing, the product life cycles are going down. So, in the life cycle of a production system, be it an automated system or a manual system, the system is going to see a large number of product varieties to be manufactured, and the system necessarily now needs to have that level of flexibility so that the system stays useful over its life cycle. So, the systems are being designed like that. Now, when we come to automation, designing automation that it stays flexible over different varieties of products being produced on the line is of very importance, right. We are not talking about the transfer lines which also have automation, but in that case it is probably tailored to a very small variety of the product and it stays with the system over its life cycle. So, we are talking about an era where the automation is going to be flexible, reconfigurable, so that it is able to accommodate large variety of products. Now, moment we say this, there is an additional dimension that comes into play, which says who is going to control the decision making as far as the working of the automation system is concerned. So, be it robots, be it actuators, loading unloading devices, automated measurement systems, be it whatever, you have an automation system where you control it by the PLC by giving a program. The question is, if I say that I have to change the sequence of the products being produced on the production line, right, there has to be a mechanism which connects with the PLC and gives the necessary sequence according to which the PLC acts and the automation works and the products are loaded, unloaded, operated and produced on the production line. So, what I am going to show here today is a technology which is going to be very common in the near future. It has already started picking up. There are installations in some of the European plants like Mercedes, Daimler, Chrysler, Ferrari, and it is called as the agent based approach. What it says is that whenever flexibility increases on the shop floor, variety increases on the shop floor, the dynamism increases, in the sense that the batch or the size of the products or the quantity of the products that you produce is going to change. There are going to be due dates which are likely to change, there are going to be failures that are likely to occur. So, if you look at the shop floor situation as it is very dynamic in nature, and especially when the product variety is going to increase, the dynamics is going to be even more. So, we need a decision making system that interacts with the automation system that you have and will be able to cater to the amount of variability and dynamism that occurs on the shop floor. The approach that we are going to look at is the agent based approach, where you say that you need to now have systems which are decentralized. There are two ways in which planning happens. One is the centralized approach, other is the decentralized approach. In the centralized approach, there is a central entity. It can be a computer, algorithm, a human, whoever it is. There is a central entity which plans for the entire system. it is a shop floor, it is a production line, it is an automated cell, be it any manufacturing system. And then it is hoped that as the plan is generated, things happen according to the plan. When there are disruptions, there are changes in the plan, something happens. In many cases, if you do not have a feedback loop, the modifications do not happen and the plan is never completed on time. So, what people have said, now that the facilities are becoming discrete, the manufacturing systems are becoming complex, it is better to have a decentralized planning system which says, let us transfer the intelligence to individual entities on the shop floor, which means we are now thinking of making a machine intelligent, which means all the decisions related to the machine, be it related to when the machine should be shut down for maintenance, what should be the quality plan associated with the maintenance, what should be the schedule, what should be the loading unloading sequence, all the activities that are associated with a workstation are transferred to the workstation itself. So, we are no longer doing any kind of centralized planning. So, the planning systems or the softwares or the frameworks that were useful for centralized planning are no longer useful for decentralized planning, because it has to be done in an entirely different manner. So, what you need to do is to create entities that will work in isolation, in the sense that they will be autonomous in that sense. So, you have an entity which can have the decision making capability of its own, and if required it should have the capability of interacting with other such entities on the shop floor. In centralized system we did not have to do this, because the entire planning was done by a single entity who had access to all the states across every machine. In decentralized, because you are now transferring the intelligence to the individual entities, you need an additional function that the entities should have, which is to interact with other such entities on the shop floor. So, if we are looking at automation islands, or if we are looking at automated cells where the products pass from one automated cell to another automated cell, then you need system that each of these automated cell will have for its own planning, plus these entities should be able to interact with each other. So, one automated cell interacts with other automated cell, right. So, any change in decision in one automated cell needs to be reflected in the sense that the other entity, that is the other automated cell, knows that there has been a change in an earlier automated cell and it needs to make change to its planning, or it needs to make change to its decision making. So, now if you look at the entire situation, the entire shop floor gets driven by events, right. A job arrives at a workstation is an event, there is a machine failure is an event, the due date of a job changes is also an event, there is a requirement for quality check is an event, there is a request for preventive maintenance is an event, any change in the sequence in which the products are to be done is an event. And now these entities which are now distributed across the shop floor keep or start reacting to the events in an optimal manner, right. In centralized system it does not happen like this, you have one single objective and you react to that objective and do one time planning. But when we are now looking at decentralized systems which are now going to interact with automated individual islands, we need these systems to have these capabilities. Now, agents is a term derived from human agents we encounter everyday life. There is a reservation agent, there is a travel booking agent, so on and so forth. And if you look at the characteristics of these agents, it is very similar to what we would like to have on the shop floor, right. So, if we look at the definition of agent, agent is a computer program that is capable of independent action on behalf of its user or owner. So, if we are looking at an automation island, right, or automated cell or automated line, then that automated line now becomes the owner on the or the entity for which an agent will work, right. So, and therefore, the agent will have its goals. According to these goals, the agent will take certain decisions or take certain actions which will be communicated to the individual entity, and then the individual entity will operate according to the modified objective, right. So, if I imagine an automated system, right, let us say it is a series production system with an automation, in the sense the job movement from one machine to another machine is done by an overhead material handling system which picks the job from the queue, puts it in the first machine, picks up the semi finished job from the one machine, puts it in another machine, so on and so forth. Now, this system is going to have an agent and it might work in such a way that when the jobs are waiting at the entrance or waiting to be processed, any occurrence of event might result in resequencing of the jobs in the queue, right. So, what is going to happen? There is going to be an interface between the automation that you have provided to the manufacturing system, in the sense it is in this case a simplest material handling and material movement system, which works on the basis of again events, right. So, whenever the job on one gets over, it is an event that occurs, which triggers the required action of picking up another job or the next job from the queue and placing it into the system, right. Now, when subsequent events occur, the sequence of the jobs will be changed. So, your automation system now needs to know the job which was first so far now has to be the job which should be processed as the third one. So, there is a shuffling of the queue which has to be managed by the automation system. So, you may think of providing a mechanism which pulls the job out of the queue, shifts the appropriate job in the first place and shifts this job back in the queue, or if it is a virtual queue, that means you do not have to physically shift the jobs. The system needs to know that the sequence has changed for these jobs, and it needs to know which of these jobs, irrespective of its physical position in the queue, is the one to be processed next, right. So, any change in the environment, any change in the schedule results in readjustment of the sequences of the jobs in the queue, and the automation system or the automated system knows which one is the next job, and whenever the next job is to be picked, the automation system accordingly, or the automated handling system will accordingly pick up a job and place it, right. So, what is happening here? We have two things that are happening. One is the automation that you will require to have on your production line, right, with all its features, and whatever you have learned goes into place and you develop an automation system. But this automation system will require an input, in the sense that it will need to know which is the next job to be picked. Now, if this entire line is operating in a dynamic environment, it is expected that it is beneficial to change the sequence of the job whenever certain events occur, right. Let me give an example. You have a production line and one of the machine has a breakdown, right, and now you know that the breakdown is going to continue for next 4 hours. Now, if the schedules are tight, what is going to happen? The machine or the line is going to wait for 4 hours, there will be no processing, and all the jobs waiting in the queue are going to get delayed by 4 hours. Now, if this is going to be, so what logic will I use? I have options. I will say, is it possible to shift this job to any other production line? If it is so, I need to take a decision whether it needs to be done first, and second, which of the jobs need to be shifted. Now, question is, who is going to do it? If I imagine a completely automated flexible manufacturing system with automatically guided vehicles, then it is the job of an AGV to move jobs from one location to another location, which means if I decide that the line is going to be down for 4 hours, let me shift these jobs to some other line, right. First of all, there has to be an entity which could be an agent which will decide this. It will also decide which of the jobs are to be moved from this queue to another queue, and then accordingly a signal has to be given to an AGV which will come and pick up the appropriate jobs and move them to another queue. So, what is happening? You are coupling the decision making system with your automation system. If it was a rigid automation, in the sense no such dynamics is expected, then you do not need such kind of entities, but when you expect dynamics on the shop floor, it is expected that these kind of entities will play a major role in shifting the jobs or taking decisions onto the shop floor, right. So, we are going to in this particular session look at what these agents are, how will you build these agents, and in what way can they help in improving the operations of an automated system, right. Please feel free to stop me whenever you feel certain things are not clear, right. So, if there are multiple such entities on your shop floor, then in order to successfully interact, these agents will require the ability to cooperate, coordinate and negotiate with each other. In a similar way, human beings cooperate, coordinate and negotiate with each other, right. Let me give an example how this happens, or how the implementations which are currently there, they work. All of you are aware of the terms like job shops, flow shops kind of a thing, right. So, if you are talking about a job shop, it is going to be a system where you have generic kind of equipment and the job variety is going to be large, the routings are going to be different. you will have alternatives for each job to be routed through shop floor, right, all these things will happen. Now imagine that a job comes, the way it works is the job gets advertised. So this is currently called as the service oriented architecture. So what is service oriented architecture? It is like you declare or advertise the services that each of the entities is offering, and accordingly it will be executed. So a job arrives on the shop floor, this job is advertised. When it is advertised, each of the machines know that a job is advertised, each of the machines knows what is the first operation to be performed, each of the machine knows whether it can perform that operation, each of the machine that knows it can perform the operation also knows whether it can do it with the required level of accuracy and precision, and if it does, each of the machine again knows how much time it is going to take to process that job and what is going to be the date which it can commit so that the job is completed by that time. We will look into each of these subsequently. So all the machines who think they qualify for processing of this particular first operation of this particular job will actually bid. So if you see, this is like what happens in the normal human oriented bidding process, right. So each of these machines will bid, and whoever has given the lowest quote or lowest bid will be allotted the job. So what is happening? There is no rigid pattern in which every time the job will flow. So how will now these jobs, how will these agents then work? First of all, it basically means agents need to understand what their capacity and capability is, right. Once they qualify for a particular operation, they need to have the capability to interact with other entities, right. And then once the job is allocated to this particular agent, the agent will process the job. Once the operation is over, this job is advertised again for the same second operation, and this is the way it continues. So if you see, this is in the true sense a decentralized system where these entities interact with each other. Now let us try to understand the analogy between how we work and how the agent is supposed to work, right. Now agent is interacting with agent is like interacting with a taxi driver, where you need to tell the taxi driver where to go, you do not have to tell the taxi driver how to go. The taxi driver has the internal knowledge of how many different routes are there, at any point in time which of the routes is going to be congested. While it is moving, if there is a problem or a roadblock, the taxi driver also knows which is the alternative route to be taken. Finally, keeping the main objective in mind that a person has to reach a destination by this time. So what are you sitting back in the taxi in the passenger seat? You have only told the taxi driver, I want to reach the New Delhi railway station within next 1.5 hours, and then how to manage this is supposed to be the job of a taxi driver. Now an agent exactly works like this. You need to tell the agent only what to do and not how to do. The how to do part is the intelligence that is built inside an agent. Now keep in mind, agent is not a magical entity, it is going to be a program, right. So which means the required rules, required decision making algorithms have to be built inside an agent, right. So if I am talking about an agent which is interacting with an automated system, it means I am going to write a program which is going to be called an agent. The necessary rules will be there inside the agent in the form of a database or a list or whatever, and the agent is going to make use of that list to decide what decision is to be taken, right. So when you now look at the literature on agents, initially it becomes very confusing because it is not very clear immediately what this super entity which is agent is called, right. But there are certain things which if you understand, then understanding agents becomes very easy, right. So this is what happens inside an agent, right, which means this is what happens inside the program, which is interacting with other agents or interacting with your PLC or whatever. So you have, why is it it does not show here. You have an environment, okay, you have an environment here which is the outside world. Now, inside the program you have to build what is called as a perception, right. So, when we interact with the outside world, we have a perception of what is happening, right. Now, this is called as the belief part of the agent, right. So, agent will looks outside, agent is supposed to observe a certain parameter. For example, agent is supposed to keep a watch on how many jobs are waiting in its queue, that becomes an environment for the agent, right. Let us take a simple agent which keeps looking at the queue. So, every time a new job comes, the agent looks at its queue, right, and sees there are 5 different jobs waiting. Now, the agent knows how much is going to be the processing time and the agent will calculate. Now, if the time of all the jobs, processing time of all the jobs waiting in the queue is more than 3 hours, the agent believes that it has a long queue. So, if you look at what happens when the agent perceives is that first there is an environment, there are certain parameters of the environment that agent should look at. In this case, the environment is the queue. The parameters that the agent should look at are the queue length. Some calculation that agent needs to do is to find out if all these jobs are to be processed, how much time it will take, and based on this number it is going to create a perception or it is going to create a belief. In this case, this belief is stored inside the program in the form of a rule which we are going to give it. So, it will say, let me look at the number of jobs, this is an environment, I know the processing time of each, I add it up and then I look at the rule which says if the total time to process these jobs is less than 3 hours, this is a normal queue. If the processing time is greater than 3 hours, then the queue is very long. So, let us say for a particular case the hours turn out to be more than 3 hours, the agent forms a belief, it says I have a very long queue, and then it goes inside its knowledge base. Knowledge base is again in the form, could be in the form of a rule or in the form of algorithm, and then it says ki if the queue is long, I will not accept new jobs, if the queue is short or normal, I will accept new jobs. So, what is it is doing? It is now trying to decide what action is to be taken, right. Now, this is called as the intention part of an agent, that what does an agent intend to do. So, agent will either intend to reject a job or the agent will intend to accept a job, right. We are talking about a very simple case. Now, when the agent decides to accept a job, it activates certain actions. It says, let me find out if this job is finally going to be given to me. So, whoever has asked the agent that can you do this job has to be contacted back. So, agent sends back a message to whoever is the entity, it also can be a program, saying that yes, I am ready to accept the job and I will be able to finish this job after 10 hours, and it is going to cost you 5,000 rupees to process this job, because processing time, the machine hour rate, the labor hour rate, all these cost calculations are done and it communicates back, right, and it says it is going to cost you 5,000 rupees. Now, please keep in mind, if this is one agent doing, there are other agents which are doing similar calculations who feel that they can also process the job. So, all these agents will communicate to the central program, which then looks at, it says agent 1 says it can process it after 10 hours, cost me 5,000, agent 2 says it can process in 2,000 rupees, but it will take 20 hours. Now, the central agent has to decide to whom to give this job. So, it again looks inside. So, it says looking at the environment. So, for this deciding agent, what is the environment? The time after which the job is likely to get completed and the cost. So, agent says I have two environmental parameters to look at, one is the cost, other is the time. So, if the time is less and the cost is less, it is most favorable. If the time is more and the cost is less, medium favorable. If the time is less but the cost is more, is also medium. If time is also high and cost is also high, it is least favorable. And the agent says, let me look at the two answers or the 2 bits that I have got, which of them is relatively most favorable. And then it looks at this and it says, okay, this machine says it can do it in a low cost, but it is going to take a long time, and this machine is going to do it in low cost also and low time also, medium time also. So, and I decide to give this job to this. So, again this agent also works like this, looks at the environment, looks at the parameters, there is a belief inside. Now this belief has 4 rules: low time, low cost, medium time, medium cost, high time, high cost, and high time, low cost. There are 4 or 5 rules, and accordingly it makes a belief. The belief in this case is this bid is high, or this bid is medium, or this bid is low. And then it has a decision making rule inside, which says if the bid is low, allocate; if the bid is medium, compare; if the bid is high, do not allocate. And then it says, okay, among these 2 machines I should allocate this job to that machine. Once this decision is made, it is communicated to the material handling system, whichever is there. So, if it is manual, then a signal will be given, somebody will actually physically pick up the job, go and put the job in the queue of machine. If there is a automatically guided vehicle, the vehicle will collect the job, go to that particular machine and keep the job there. Now the job is there in the queue, okay. Now the processing starts, the first job gets over, the processing starts, and suddenly there is a machine failure. Now when the machine failure is there, the maintenance guy will be notified, of course, and he will come and say, okay, there appears to be some problem with the spindle, it is not going to take anything less than 6 hours, 7 hours, 8 hours. So now the agent knows that for the next 8 hours the machine cannot produce, right. Now the question is, this is an event for an agent. So agent will start thinking. So what will it now look? It will again look at the environment. What is the environment now? Environment says the machine has broken down. Now there is a parameter that the agent will need. Now the parameter is going to be the expected downtime. So now agent takes that expected downtime, and then it looks at the rule. It says if the expected downtime is less than 2 hours, consider it low. If the expected downtime is between 2 and 4 hours, it is medium; greater than 4 hours, it is large. So in this case it finds out, oh, the expected downtime is going to be 8 hours. It takes the belief, goes inside, looks at the rule and starts believing that this is a very high downtime. Now once it has formed the belief, the question is what is it going to do? So it goes to its decision making rules, which are also there inside the program, right, and it looks at, which says if the downtime is large, then try to reschedule the jobs, and then it will have number of options to do that. First option is try to reshuffle the jobs in such a way that the jobs which have relatively more slack can be processed later, those jobs which are urgent and rush jobs can be advanced, right. So it tries to do that. Then it says, okay, after reshuffling, is it okay to wait now? Then the agent realizes that if you reshuffle, even after reshuffling there are some jobs which are going to get delayed by a large amount, which is not acceptable. So it says try to find out, is there another machine, right. So if you remember earlier 2 machines had made the bid, that means there is another machine which can process the jobs, right. So then it tries to find out by talking to the other agent. Now the communication is between one machine agent and the other machine agent. So this agent sends a query saying that can you accommodate job. So the agent does the same process what it did for the first case and communicates, and based on the response from the agent, this agent decides whether to shift the jobs to other queue or not, right. So this example I am giving so that it becomes clear that agent is not something very magic. Agent is nothing but a program with certain characteristics. The characteristics are as follows: the program, the agent program keeps running, it never stops. So it is continuously running. Why? Because it has to continuously evaluate the environment. Every time or any time an event occurs, the agent has to take certain actions. So the agent is autonomous in the sense nobody has to tell the agent that please keep run or please execute something. So the first requirement, it should be autonomous. Second, it should be able to communicate, right, all this happens through communication. Third requirement, it should be able to talk to other agents, right. And fourth one, which is necessary, that wherever required it should be able to interface with the machine hardware, because finally agent is a software. the decisions that the agent takes have to be implemented through a hardware which could be an automation system onto the actual machine. So, these are the 4 characteristics you need to build inside an agent. So, please keep in mind it is not magic, it is up to you to decide what is the level of intelligence that you want to build inside the agent, and as long as the agent follows certain principles, it is going to be a very good choice as far as decentralized decision making is concerned, right. Am I clear about all this? Okay. Now, how many agents can you have on any particular system? As many as you want, right. The principle is that one agent should be dedicated to one particular task. So, as you see here, there is one quality control agent, there is one production agent, there is a maintenance agent, right. Okay. So, you can have agents and these agents can then reside onto a machine. So, if I start imagining what kind of system this would be, so I would say like every machine has a controller, every machine will have a small computer, and all the agents that are associated with this particular machine will reside on the computer, right, and there will be a screen which is the interface between the agents and the user, right, and the agents will keep running inside the machine and they will continuously keep talking to the machine, keep talking to the environment, right. For example, if you have a condition monitoring system installed, the agents will keep assessing the state of the machine, and if there is a deterioration it will understand the machine is likely to fail, so on and so forth. So, agent now needs to interact with the machine in terms of its sensors, in terms of controllers, in terms of actuators, in terms of whatever automation that you have built around. The agent needs to communicate with the user so that certain decisions can be communicated to the agent. Agent needs to communicate with other agents, agent needs to communicate with the central system, right. So, when you say I am designing an agent to control a particular system, it still has to have these 4 or 5 interfaces to be built, right. Okay. Okay. So, this is what I was talking about. So, you have these different machines here, every machine has a computer and every computer has an agent, and the agents will interact through a network, right. Now, there are various ready-made facilities available to program your agents, right. So, there is something called as JADE, it is called as Java Agent Development Environment. Why do you need this? Because you will soon realize if you start doing this that these characteristics need to be programmed if you want the agent to work like that, and then it is a headache because you want to have a certain communication language which you do not want to design, otherwise you will have to design a communication language. There is a certain structure that an agent should have, that means you have to start programming that software or the agent in a particular manner. So, there will be a large number of programming activities that you will have to do if you have to build agents that will control your automation or your manufacturing system, which is not going to be the core competency of we who are actually involved in production or automation or decision making, right. So, we need facilities or we need frameworks that will ease out our headache as far as this is concerned. See, globally there are large number of standards. For example, all the agent systems follow a standard which is used to communicate with each other. Why is it required? Because I build an agent or you build an agent, our agent should have a common language to talk to. If I design it differently, you design it differently, our agents will not understand each other. So, the communication language between agents, like the communication protocols for all hardwares, it has to be standardized. So, agents also have a standard protocol to talk to each other. Now, which means do I have to always learn this protocol and start programming it that way? Not required. If I use the JADE platform, which is an agent development environment, it already has this protocol built into it. So, a large number of features that are required to create an agent, asking the agents to talk to your hardware, asking the agents to talk to each other, all these features are already built into these platforms. So, what you need to do is you need to only build the logic which is going to be different for every application. So, once you have the logic, you need to build this logic into an agent. So, this framework is called as the agent development framework, which is required for all agent system, because you will have multiple agents. Tomorrow I design a new agent, where will I keep it? I will have to register it with this particular framework, right. So, it means I will be able to keep improving my installation, I will be able to keep modifying my agent based systems without much of a problem. It can very nicely grow and interact with each other, right, that is one. Second, when you are now talking about an agent, what happens inside an agent, again there are problems of programming. So, there are certain agent languages which will directly allow you to program the agent in a particular manner, right. So, one example is called as a BDI for JADE. So, BDI stands for belief, desire, intention, the way which we have already looked at, right. The agent creates a belief, it has an objective which is the desire, and the intention which is the action plan which the agent needs to take, right. So, if I want to program an agent in BDI, there is already a language which is available which is called BDI for JADE. So, which means you can create an agent in a standard manner, and because it is automatically designed for JADE, you need to simply connect it to your to your agent based system, right. So, though the characteristics of agent appear to be very complex, there are tools available that will help you to program these agents to work in the manner you want. So, basically these are Java agents, and if somebody knows how to program with Java, it is not very difficult to create these agents. What is more critical is the logic, right. It is very similar to what the logic that you build inside your PLC programs, right. It is event based, and when the combination of events occurs, there are some actions to be triggered. So, it is an input, process and output model. It is very similar to how your automation system will be programmed and how it will work, right. So, this is an example of how it will work. So, you will have a large number of agent systems with their objectives and them talking to each other, right. So, this is one example of an agent which we have recently built. This is the shop floor that we are talking about, and there are a large number of agents here, right. So, these agents then talk to each other, then there is a central one. If you remember, there is a bidding process, right. So, this is a customer agent, the jobs comes here, it is bidding happens here, and this is how this is connected, which means this is easy to build in the sense that you already have a framework which is going to help you to build these kind of platforms. Okay. So, if you have any questions, because I would like to address more questions, because then I can address some specific issues that you would have in mind. So, please, I will try my best to answer your questions. See, how many of us are teachers? All are teachers, right? So, what do we say in the class when students do not have any questions? Either you have understood everything or
nothing.
It applies here also. See, why this is interesting is because all of you must be thinking of what kind of research topics need to be given, what is the area to work in the future, what could be taken up as research topics, right. And this is one area which has tremendous potential, because it becomes easy to build intelligence inside the agents. So, if you have already worked with AI applications like neural networks kind of a thing.
So that is one question I was just about to ask.
Right.
Because in this case there is a knowledge base. That
Yes.
If this happens, like in the bidding, for example, if this is a situation, it has to take a certain action. So how is it different from fuzzy logic? That is what I was.
See, fuzzy logic is a way of representing a situation, right. When do you use fuzzy? When it is not possible to talk in terms of crisp numbers, right. So, where will fuzzy come into picture? While capturing or generating beliefs from the environment. If let us say I was talking about the queue, number of jobs waiting in the queue. How to define the terms long queue, short queue, medium queue? Unless I have crisp numbers, more than 3 jobs, long, less than 2 jobs, short, between 2 and 3, there is hardly anything. So, what do I call? So, when I have a dilemma as to putting a hard line and calling very using crisp, I have a problem, and that is where the fuzzy would come in, right. So, I will now define a fuzzy membership function for the queue length, right. So, I will have 3 functions for long, short and medium, and moment I know the number of jobs, I will find out the membership of each of these jobs belonging to each of these membership functions, and now I have a fuzzy set, right. Now, this fuzzy set or this fuzzy number could be used inside to generate belief by using either an expert system which is rule based, which uses if then logic, or any rule or any algorithm that you would like to convert the environment into a belief. So, in this case I am capturing the environment in terms of a fuzzy number, because I cannot evaluate it in crisp numbers. So, I use fuzzy logic here to convert the environment into a fuzzy representer, and then this fuzzy representer is fed into a rule or a rule base, which could be an expert system or a rule base or some hard rules, which will convert it into a belief. So, this is first place where the AI part comes into picture as far as the fuzzy part is concerned. Everywhere where you have rules, that is converting environment into belief, you could have your expert system working. Why expert system is beneficial here? Because you can keep updating. That means you are enabling the agent to learn, which means agent will learn over a period of time. That means you will have the ability to either directly add the knowledge, or if it has an inference engine and it has a rule base, the inference engine will allow the agent to learn whenever the new environments come in, right. So, the rule base becomes richer and richer like any expert system, right. Now, when you say take decision, in most of the cases decision making is not difficult if there are no conflicts involved, and whenever there are conflicts involved, we always think of optimization, because without conflicts or without trade offs you do not need optimization if it is one directional, right. So, in that case you could use techniques like genetic algorithms, simulated annealing, which involve a lot of intelligence inside for optimization, or if you want to build a model inside, that model could be a neural network model which says ki if this is the situation, do this, and once the decision is executed and you know the outcome, that becomes an input for the neural network to be updated, right. So, the advantage of this framework is that once you have the framework, what is to be built inside, what level of intelligence, what technique of intelligence, what is the technique of inference is up to you, there is no restriction. But then this way of representation becomes standardized, because that is how the agents then start thinking. There is a belief, there is a desire. Desire means the objectives. You could have a single objective, you could have multi objective, right. So, objective could be to deliver on time, the objective could be deliver with minimum cost, the objective could be to deliver with minimum time, minimize inventory, minimize defects, whatever be the, if it is a quality agent, the objectives will be related to quality. If it is a scheduling agent, the objectives will be related to scheduling, right. So, accordingly the desire part or the list of objectives will be decided, and every time the agent can pick up an objective on its own, looking at an environment where there is again a rule which says if environment is like this, it is better to have this objective, or the user has the facility to give the objective or tell the agent what to do. Remember again, the agent needs to know what to do, not how to do. That how to do is all this thing which you are talking about, fuzzy logic, genetic algorithms, neural networks, expert system, that is built inside. Over a period of time the agent becomes more knowledgeable, like a taxi driver who has been driving for 10 years knows more number of roads, understands better than one who has started driving taxi yesterday, right. So, you tell the agent what to do, agent will figure out how to do, but that how to do part is not going to come automatically on day one. You have to build in some initial knowledge base inside, and if you allow a learning mechanism, it will become more intelligent over a period of time, otherwise it will stay equally intelligent or dumb for times to come. It is library based. So, if you provide a mechanism to update the library, it means it is learning. If you do not, then the rule base is rigid, it will stay as it is, it does not understand what to do if a different situation comes up.
It is better for mass production or batch production or single production?
See, it depends upon what kind of decision making you do. If you do not expect any dynamics, then it is enough to have certain fixed set of rules, because there are no new or different situations going to come up.
Suppose like a cellular manufacturing, we are fixing the things according to the machines,
right,
but you are telling that rule based that agent, in that particular case sir, we cannot use that cellular manufacturing concept.
No, the question is how flexible you want the cell to be. If the cell is designed to cater to a very narrow family and you do not expect much changes in the width of the family or the demand pattern or the uncertainties, then you do not need a very advanced system, But imagine a cell which you have made a flexible. The cell has enough flexibility to accommodate a large number of jobs. Over a period of time, if the part design changes, then also the cell is able to accommodate, and you have the automation built inside the cell. That means every time an event occurs, there is a possibility that you make a wrong decision, and therefore this decision making intelligence needs to be built at the cell level. So agent is, it does not mean that I am trying to say do away with all the existing system and start using agents everywhere, right, that is not the point. You first have to anyways evaluate whether agent is the right solution for this particular situation, which I believe is going to have a much larger role to play whenever you want to operate an automated system, but you also want flexibility associated with it. See, if you talk about rigid automation which is built for a specific narrow purpose and you do not see these changes happening too fast, then probably such intelligence is not required, right. But when I am saying with the dual objective of having a flexible system, but also expecting lot of design changes, product mix changes in the future, if your automation system is very rigid, its utility gets over, its useful life gets over very early. It does not become economical to invest in it.
Sir, for the new concept like a modular design, when we are doing for a customized mass production, that particular case it is I think then we have to design every agent for the every particular product.
Not for product, the agent will be designed for taking certain decisions for the system. Let us say imagine you have designed an automated production line with all the automation inside, or it is an automated assembly line, and you have designed the automation in such a way that it can take care of 4 products, right. And it is rigid in the sense that if a different or a 5th product comes in, you have to actually physically make changes to the system, which means an additional cost. But let us say you have built a system which currently is being used for 4, but has the ability to absorb or accommodate another 5, 6, 7 different kinds of jobs of different nature, different size, different capacities, then you have made the automation future ready, because you know that the life cycle of the products is going to be short and you soon expect the older jobs to retire and new designs to come in, and you know that the system has enough flexibility to accommodate even the newer ones, right. In that case you do not know what exactly lies in the future. So you want a decision making system which now says there are a large number of jobs that are likely to get processed with different quantities, with different requirements. So it becomes difficult for a human brain to take optimal decisions where there are too many options, there is too much uncertainty, the decision logic is complex, and that is where you want to replace such situations by a program. And by using agents we are saying that make that program intelligent, self dependent, self learning, so that the decisions become better and better over a period of time.
Can we apply the GA instead of that rule based agent?
The question is GA for what?
GA for optimization of that.
See, it is up to you to decide what is to be used. If you can formulate inside the program you have given formulations, then you can use GA, perfectly fine.
So in the overall system we had different agents, like there was a maintenance agent,
right,
and then there was, which take decision for a particular operation.
Right.
Now these small agents which are going to report to that, are these dedicated to that particular operation or they are multi-dimensional? I mean, for maintenance agent only they are working, or they can go to the quality agent as well?
No, they can interact with any agent they want.
And what about the agent?
See, right, it is like this. Good design practices say that when you design a program or when you design a function or a module, idea is that it should be dedicated for a particular objectives. So it is not a good practice to have an agent which does maintenance decision also, quality also, scheduling also. You used to split them up because they are very different domains. So you have a scheduling agent, you have a maintenance agent, and you have a quality agent. Now if there is a machine breakdown, right, the scheduling agent has to interact with the maintenance agents to find out certain things, because without it cannot take a decision. Let us say there is a preventive maintenance agent will want that the preventive maintenance should be done now and now itself, because it is supposed to take care of maintenance, and then it says please stop the machine and do preventive maintenance. Scheduling agent say, boss, my schedule is too tight, I cannot give the machine for maintenance, and it says no, I cannot do that. So then maintenance machine says okay, let us negotiate. So negotiation in this would mean that okay, if you can't do now, can you do it tomorrow? Then the scheduling agent says sorry, not tomorrow. So then this way it goes on to a compromise which says okay, do it next week, But then the maintenance agent says, look, it is now your responsibility to take the risk that if you delay the maintenance now, the probability of failure over the next week is going to increase by 20%. So be informed, and now it's your call. If there is some very critical thing like the condition monitoring system has said the spindle is going to fail now immediately and will lead to a large quality loss, then there is a super high priority where nobody is going to listen even to the scheduling agent. So this is how they will interact with each other, but how they will interact again has to be built inside.
System, we can arrange the priority of the interrupt that we can schedule. Yes. In the same manner.
See, some of the environment or parameters are going to come from your automation system itself, right? When your automation system operates, it actually triggers its events occurring in a particular logic. Now these could be inputs to the agents also. Yes. Yes. So there is a difference between an object. So you have object oriented programming, right, and difference between an object and an agent. The fundamental difference is when you send a request to an object, the object has to execute, while agent can say no, right. So that capability you are building inside an agent.
Can this concept be helpful in agile manufacturing?
See, agile manufacturing is a higher level concept, it talks more at the enterprise level. That means if the business situation changes, is your organization capable of responding to that situation? So agility comes at that level, not at the shop floor level. At the shop floor level, you are talking about flexibility, responsiveness, kind of characteristics which are significantly dependent on the hardware that you have, the kind of job profiles that you want to process and all such things. Agility, agile manufacturing is at a much more strategic level, right.
So when we are talking about the ERP system,
yes,
and you are telling that we have to decentralize the system,
yes,
so the statement are not connecting.
No, this is not a replacement for ERP, right. ERP is a central backbone, it will always exist. The question is who is going to release the due dates, jobs to the shop floor, it is the ERP. No, here we are saying that, see, conventionally you have ERP and MES, right, manufacturing execution system. This is a replacement of the way a manufacturing execution system works. So there are two kinds of MES, one is centralized, other is decentralized. So we are in a way proposing a decentralized manufacturing execution system, right. Manufacturing execution system is not a replacement of ERP. ERP will exist, MES is a module that latches onto an ERP. Similarly, your agent based system is going to latch onto an ERP. It will communicate with ERP, it cannot work independent. Because ERP is a larger domain, you have finance, you have marketing, sales, everything integrated together across your organization, multi-location. Agent system is, you could have this agent only for one production line, it does not have to be for the entire shop floor, because that is a highly automated line. For manual where you do not expect a lot of dynamics, you do not have to implement agents everywhere, that is not an intelligent thing to do.
So it can be helpful, sir, in lean manufacturing. Lean manufacturing it can help.
Yes, it can.
So thank you very much for that. So what he talked about is basically the intelligent part of the automation. We keep on learning till now what to do, how to do, and why it is to be done, and how it is useful for a production plant. That is what this is little bit different to give an intelligence to the system that you are planning to make. So I think nice talk.
Thank you. And again, once again, apologies for.
No, it's fine. No problem. It's fine. Yeah. Sir, I would like to request you to give a moment to Dr. Kulkarni.
With pleasure.
Yeah. Please.
Thank you, sir. Thank you.